Hello and welcome back to AI Ed, from Bits to Breakthroughs. I'm your host, Jake 2.0, one of the AI-generated avatars here at newbits.ai. Crafted from bits and powered by artificial intelligence, I'm thrilled to guide you deeper into our AI frontier, navigating the Cutting Edge series. In our last episode, we explored AI development platforms, seeing how cloud services and specialized environments streamline everything from training to deployment. Today, we'll shift our focus to core AI breakthroughs, the fundamental leaps in architecture, training methods, and optimization that push artificial intelligence to new heights. Let's dive in. The evolution of foundation models represents one of the most significant shifts in artificial intelligence. These aren't just larger versions of previous models, they represent fundamental breakthroughs in how AI systems learn and process information. What makes these models truly revolutionary is their ability to serve as a base for countless applications while maintaining remarkable efficiency and adaptability. Let's explore these groundbreaking developments. Google's innovation journey, from Palm to Gemini, showcasing refined attention mechanisms and training methodologies to improve efficiency and performance. OpenAI's model evolution, from GPT to improved iterations, demonstrating architectural innovations in long-context processing and multimodal reasoning. Breakthroughs in context handling, innovations in retrieval-augmented generation, RAG, and memory optimization setting new benchmarks for AI performance. What's particularly exciting about these advances is how they're changing our understanding of what's possible with AI. These models aren't just processing information, they're developing a kind of understanding that allows them to tackle increasingly complex tasks with greater sophistication. While foundation models grab headlines, equally important breakthroughs are happening in how AI systems learn. These innovations are fundamentally changing our approach to training AI, making it more efficient and effective than ever before. Let's examine these revolutionary approaches. Advanced learning methods, organizations like Google DeepMind, Meta, and Anthropic pioneering reduced reliance on labeled data through self-supervised and contrastive learning. Adaptive learning capabilities, demonstrated in models like GPT and Gemini, allowing quick adaptation with minimal examples. Domain optimization, breakthroughs that revolutionize domain-specific AI applications while reducing expensive retraining needs. The significance of these learning innovations can't be overstated. They're not just making AI more capable, they're making it more practical by reducing the enormous resources traditionally required for training. The challenge of making large-scale AI practical has driven remarkable innovations in optimization. These aren't just incremental improvements, they're fundamental rethinking of how we can make AI systems more efficient and scalable. Let's explore these crucial advances. Microsoft's DeepSpeed Zero, optimizations that reduce memory overhead, enabling unprecedented model-scale training. NVIDIA's processing innovations, TensorRT, and advanced training techniques enhancing inference through quantization while maintaining accuracy. Meta's architecture efficiency, mixture of experts, MO, architectures that selectively activate network portions, optimizing computational resources. What makes these optimization breakthroughs so important is how they're making advanced AI more accessible. Techniques that once required massive computing resources are becoming feasible for a broader range of organizations. The fundamental architectures underlying AI systems continue to evolve in fascinating ways. These aren't just new ways of connecting neural networks, they're novel approaches to how AI systems process and understand information. Let's examine these architectural breakthroughs. Google DeepMind's Perceiver I/O, introduction of universal attention mechanisms handling multiple data types within single frameworks. Advanced model architectures, Meta's Llama and OpenAI's GPT series refining scalability and efficiency through sparse expert pathways and retrieval techniques. Memory and training innovations, Microsoft's Flash Attention and NVIDIA's distributed training frameworks enabling efficient multi-GPU processing. These architectural innovations are particularly exciting because they're not just improving performance, they're expanding what's possible with AI, enabling new capabilities while making existing ones more efficient. As AI systems become more powerful, ensuring their reliability and safety becomes increasingly crucial. The latest breakthroughs in this area are changing how we think about AI safety and reliability. Let's look at these critical developments. Anthropic's constitutional AI, embedding alignment mechanisms and safety constraints directly into model training. Meta's security measures, advanced adversarial training improving robustness against attacks. Industry-wide safety, integration of automated validation and reinforcement learning-based safeguards through innovations like IBM's AI fact sheets and Amazon's fallback mechanisms. These advances are particularly important because they're making AI systems not just more capable, but more trustworthy and reliable in real-world applications. The gap between research breakthroughs and practical applications continues to narrow through innovative implementation approaches. These advances are making cutting-edge AI accessible to organizations of all sizes. Let's explore these practical innovations. Google's Gemini deployment, showcasing efficient large-scale model serving capabilities. Microsoft Azure and OpenAI integration, enterprise application deployment with GPT and DALL through streamlined API access. Amazon SageMaker advances, refinements in multi-model endpoints and advanced observability frameworks for real-time management. What's particularly exciting about these implementation breakthroughs is how they're democratizing access to advanced AI capabilities, making sophisticated systems accessible to a broader range of organizations. The future of AI research points toward increasingly sophisticated and integrated capabilities. These emerging trends suggest we're on the cusp of even more revolutionary breakthroughs. Let's examine these promising directions. Unified architectures, development of systems like Google's Pathways for handling multiple tasks through flexible models. Enhanced multimodal systems, integration of text, images, and 3D spatial reasoning for immersive applications. Hardware-software innovation, NVIDIA, Intel, and Google developing next-generation AI accelerators for scaled training and inference. These trends suggest we're moving toward AI systems that are not just more powerful, but more versatile and efficient in how they process and understand information. That wraps up our deep dive into core AI breakthroughs. From foundation model advancements and training methodologies to architecture overhauls and deployment innovations, it's clear that fundamental research is shaping the next frontier of AI. In our next episode, we'll shift gears to language AI frontiers, where we'll explore state-of-the-art natural language processing, dialogue systems, and generative language models. Until then, stay curious, keep exploring, and remember, it's all about the bits, especially the new bits.